panacea for big data challenge is real-time IT operations analytics. And within the context of end-user computing, real-time analytics is critical to understanding and correlating device and activity with application SLAs from the vantage point of the end user. Real-time analytics also empowers organizations with the intelligence they need to dramatically reduce business disruption through automated cause analysis. So at the heart of the Aternity FPI platform is a real-time analytics and event correlation engine. For every application performance metric we collect, we automatically generate an autonomic performance profile or a baseline. Now these baselines are automatically regressed or split by location, by subnet, by target server, or hardware configuration, for example. And this is all done out of the box without any user definition whatsoever. So you have the most granular baseline for each or any group of users that are experiencing the same performance. In addition, manual thresholds can be set to complement these automatically generated baselines. And manual thresholds are very helpful in SLA management, for example. Now, as soon as performance deviates from the baselines or thresholds, a problem is automatically detected. Alerts are generated, and the trouble tickets in the ITN system that Dave mentioned are opened. The business impact is analyzed. The impacted users are isolated and identified, and the probable cause is classified. And Aternity continues to monitor the problem throughout its lifetime, closing the problem automatically once performance returns back to normal. As our final demo of the day, Ravi, let's take a look at incident detection. The Aternity Incident Dashboard you're looking at displays all end-user incidents within an organization. For each incident, we can see the impact severity, the time the incident was detected, the application and associated activity that is impacted, the number of impacted endpoints, and the current state of the incident. The maximum number of impacted endpoints shows the total number of users who were impacted concurrently at any time throughout the entire incident. Everything, of course, is updated in real time. The group column shows which part of the user population is impacted by a particular incident, and it highlights the FPI platform's ability to detect and escalate incidents based on specific groups of users. Currently, we see that incidents have been detected for Outlook, for SAP, the Clinical Manager application we've seen previously, and online banking apps. Ravi, drilling down into the Outlook incident for a moment, we see the impact analysis details, whose first section provides us with a summary of the details we saw on the incident list dashboard. Let's collapse that so we get a bit more real estate. Great. The next section provides us with some powerful analysis of the incident impacts. The pie chart shows us about 3/4 of the total Outlook user population is impacted. By default, endpoints are grouped by location, but we can also group by department, by subnet, by office, or other attributes such as operating system, browser type, machine type, etc. Grouping by subnet shows us that the impacted users come from multiple locations. That's probably a good indication that the problem is not network related. The classification or probable cause analysis for this incident points to multiple possible causes sorted by probability. The probable causes identified with the highest grade are the Dell Latitude D620 machines, machines with Windows XP SP3, and the New York location. The most probable cause points to D620 machines. This is because the majority of impacted users are using D620 machines, and few of the non-impacted users are using this model. The other two causes received the lowest score because although most impacted users have XP SP3 on their machines, other users of Outlook with this exact service pack are not impacted by this incident. And the same applies to users from New York. Ravi, now that we understand the cause of the problem, let's dig deeper into the timelines of the incident and who exactly is impacted. The incident time machine allows us to navigate the timeline of the incident while analyzing the incident impact at any time. moving the time bar across the incident lifetime dynamically updates all the incident impact analysis components on the form, such as the table view of impacted endpoints below. We can expand the detail level to get a view of the incident timeline for each endpoint. And we quickly see the status of measurements of that endpoint throughout the lifetime of the incident. Clicking on any of the highlighted status blocks shows us the actual activity measurements for that endpoint and their deviation from either the automatically generated baselines or the thresholds. From here, we can either go to the Navigator for further analysis or the Endpoint Dashboard. Ravi, as we've already toured the Navigator, let's see what we can learn from the Endpoint Dashboard of user Ryan. The first thing we glean from Ryan's dashboard that he's using a physical desktop as opposed to a Citrix session or a virtual desktop or a mobile device. The dashboard provides us with the time machine capabilities we already discussed earlier. A quick glance shows us that Ryan is using about half a dozen applications and having some major issues with Outlook only. Ravi, let's expand the Outlook application view and drill down a little deeper. The activity section shows each deviating Outlook activity Ryan has performed during our selected time frame, immediately highlighting the performance of Open Inbox and perhaps Send Mail as deviating. We can also see the correlation of desktop resource consumption and applicational transactional performance at any time. Toggling between viewing all activities performed or only those that are deviating give us a clear indication of Ryan's overall experience of Outlook and his activity level with Outlook. Now, drilling down into the host resource view will help us identify where the host resource consumption is also responsible for the poor Outlook performance Ryan is experiencing. The Aternity FPI platform automatically identifies, as we discussed, and presents the most deviating host resources first. And it shows us that CPU usage of Ryan is very high and the available memory is very low. When clicking on the CPU spike, top process list below gets filtered accordingly. And we immediately see that the search indexer process is causing the high memory and that weather bug is the cause for high CPU. I'm sure many of us have seen that problem on our own machines.